Find the first four partial sums and the nth partial sum of the sequence given by b sub n equals 1 over n minus 1 over n plus 1. Let's start by looking at the individual terms of the sequence here. The first term, b sub 1, we can find by putting in 1 for n. So b sub 1 gives us 1 over 1 minus 1 over 1 plus 1, which is 2. So we've got 1 over 1 minus 1 half. And if we wanted to, we could find a common denominator, 2 over 2 minus 1 over 2, which gives us 1 half for the first term. Let's take a look at the second term. In this case, this will be 1 over 2 minus 1 over 2 plus 1, or 3. And again, we would need a common denominator if we wanted to figure out what this is equal to. In this case, it's 6. It's going to be 3/6 minus 2/6, which gives us 1/6. Then we've got b sub 3. This is going to be 1/3 minus 1/4. It's going to be 4/12 minus 3/12, which gives us 1/12. And for the fourth term, b sub 4, we've got 1/4 minus 1/5, which is going to be 5/20 minus 4/20, which gives us 1/20. So we can see what these individual terms are. Now, to find the partial sums, we know that we can add the terms together. The first partial sum is 1 half. The second is going to be 1 half plus 1/6. The third is the sum of the first three terms. And we're going to do this, but then we're going to look at a clever way to get the partial sums with less work. So we're going to do this problem twice, looking at the partial sums. First, let's do it straightforward. The first partial sum is just the first term, which in this case is 1 half. The second partial sum is the sum of the first two terms. So we've got 1 half plus 1/6. The common denominator here is 6. So we've got 3/6 plus 1/6, which is 4/6, or 2/3. All right. Now, for the third partial sum, we need to add together the first three terms. That'll be 1 half plus 1/6 plus 1/12. The least common denominator here is 12. So we can rewrite these fractions as 6/12 plus 2/12 plus 1/12. That is going to be 9/12, or 3/4. So we've got 1 half, 2/3, 3/4. I think you're seeing a pattern here, but sometimes patterns can be deceiving. So it's good, especially if there's only 3 terms so far. So it's good to actually do out the fourth one. So we've got 1 half plus 1/6 plus 1/12 plus 1/20. Here, the least common denominator is going to be 60, which is quite large. So the calculations are going to be more involved. 1 half is 30/60. 1/6 is 10/60. 1/12 is 5/60. 1/20 is 3/60. When we add these together, we get 48/60. This reduces by a factor of 12, giving us 4/5. So our partial sums are 1 half, 2/3, 3/4, and 4/5. If we wanted the nth partial sum, we can notice here that the numerator is always going to be n, and the denominator is 1 more than that, so the nth partial sum is going to be n over n plus 1. There is a second way that we can do this problem. It's going to have fewer calculations. We're going to need fewer common denominators, which is really nice. And this method uses the very beginning where we just wrote out what each of the terms is as a difference. So what I want to do is I want to use these now to come up with the partial sums. Now the first partial sum is going to be 1 over 1 minus 1 over 2, which we've already calculated. We know that gives us 1/2. For the second partial sum, we know that this is the sum of the first two terms of the sequence. I'm actually going to write it out like it is, 1 over 1 minus 1/2 plus 1/2 minus 1/3. And we actually notice that the negative 1/2 and the positive 1/2 are going to end up canceling. And so we've got 1 over 1 minus 1/3, and 1 minus 1/3 leaves us with 2/3. So we've got 2/3, but we have less work to get there. We didn't have to come up with all of these common denominators and subtract and do all of that. We get there a little bit faster because we've got some cancellation. Let's continue to look at the third partial sum. We've got 1 over 1 minus 1/2 plus 1/2 minus 1/3 plus 1/3 minus 1/4. That's just adding up the first three terms as we have over here. And we notice we've got some cancellation. The 1/2 and the 1/3 both cancel out. And so we end up with 1 over 1 minus 1/4, and 1 minus 1/4 is 3/4. I think you can see what's going on here. For the fourth partial sum, we're going to have a bunch of cancellations as well. Let's see, minus 1/4 plus 1/4 minus 1/5. So here we've got the fourth partial sum, and we've got even more things that cancel. The 1/2, the 1/3, the 1/4 cancel, and we can see that we've got 1 over 1 minus 1/5, and 1 minus 1/5 is 4/5. And so here, if we wanted to find the nth partial sum, we're going to have 1 over 1 minus 1/2 plus 1/2 minus 1/3 plus ... all the way up to the nth term, which is 1 over n minus 1 over n plus 1. And again, everything is going to cancel except the first and the last terms. And so here we've got 1 over 1 minus 1 over n plus 1. The least common denominator here is n plus 1. So we've got n plus 1 over n plus 1 minus 1 over n plus 1. And when we subtract the numerators, we're left with n over n plus 1, which is the same answer that we got before, except before, instead of looking at each of the individual sums and trying to find a pattern and supposing that that pattern is correct, here we can actually see that this pattern works because of the cancellations, and we get the same answer. This might have seemed a little bit more confusing to you, but it's an argument that's used in a lot of situations in math when we're adding together things that are differences because we've got positive and negative terms that can often cancel out. And so even if this was a little bit more difficult or abstract for you, it's good to see how it works because it's something that you can use again later on in this course and also in calculus.